স্যার আসসালামু আলাইকুম।
ওয়ালাইকুম আসসালাম রহমতুল্লাহ। জি স্যার, কেমন আছেন স্যার?
জি আলহামদুলিল্লাহ।
ওয়ালাইকুম আসসালাম স্যার।
জি আমরা শুরু করি স্যার। যে গুড ইভিনিং টু ইউ অল। We are in information technology CS certificate level, and we are discussing LO3 to LO7. Then we will start for learning object 8. So within LO6, lastly we have taken one class. Now today we'll discuss from LO6 telecommunication network topologies, types of network topologies, bus, sister, ring, hybrid, tree, mesh topology, etc. Network protocol, network architecture, and peer-to-peer network, P2P, client-server network, telecommunication or telecom satellite network, switching, and the types of switching, network interoperability, VPN, virtual private network, TCP/IP model, OSI model, and what is the difference between TCP/IP model and OSI model, telecommunication and network security, etc. For from these topics, LO6, telecommunication network. Let us start with network topologies. So what is network topologies? We know it refers to the physical or logical arrangement, computer, switch, router, etc. As we can say that nodes and connect to the network. And we know it determines how data flow and impact performance, reliability, and scalability. And if you see here, there are different types of network topology. One is physical topology, another logical topology. Physical means layout of devices, and logical means how data flow. So physical topology, the bus topology, ring topology, star topology, mesh topology, tree topology, hybrid topology, etc. And here if we see that are the ring topology, mesh topology, star topology, full connected, that means topology, fully connected, each and every point, they connect each and every. Bus topology, tree topology, line topology, and logical topologies are how data flow. We can say they are logical bus and logical ring. Logical bus, that means Ethernet. That means data is broadcast to all nodes. And logical ring, that means ring topology, if you see here, this one, data pass sequentially. And now if you see the um, if you see the each and every topology, briefly we can discuss here. Think about a star topology. Look, this is the activities of a star topologies. So all devices connected to a central hub. Look here, all devices connected to a central hub or switch. If we see here, that means the cloud server, here the switch or hub that connected each and every devices. So it's easy to manage, and failure of one node doesn't affect other, because if this piece is fail to connect, but other is working, So easy to manage, and failure of a one node does not affect others. And if central hub fail, they disable the entire network, all of the clubs. So, example, our home Wi-Fi network. If centrally Wi-Fi router fail, then we will not be able to connect the Wi-Fi. So this way, here the star topology, and if you see the bus topology, look, this is the bus topology. So this topology, all devices share a single communication line through this backbone cable, one line. It is simple and cost effective for a small network. আজান দিচ্ছে, আমরা একটু অপেক্ষা করি, আজানটা শেষ হয়ে গেছে। So we are discussing the bus topology. Here, all devices share a single communication line. Look here, is the through the backbone cable, and simple and cost-effective for a small network. But a single cable break can disrupt the whole network. If one cable break, then whole network can be collapsed. So it's the bus topology. And now if we see the ring topology, look here, based on that ring topology. So ring topology and devices are connected in a closed loop. Look here, all are connected in a closed loop and passing data in one direction or both. That means data passing through this way, each and every point, they interacted through a loop and equal access for all devices. All devices, they have the equal access. But one single node failure can break the entire loop, just like bus topology. So here is a rings topology. Now the tree topology. Tree, look here, like a tree. So is the combined star and bus topology. Star and bus topology combination is tree topology. And it is a scalable, good for large network, but dependent on root node, is dependent on root node. If it's fail, then that it can be collapse. So your corporate network with multiple department using that type of tree topology within big organization. Now the hybrid topology. Hybrid, it means combination of more than one or two topology. We know a mixed or two more topology. For example, if we see here the star and bus both combined in the hybrid topology, either star and bus. So it's flexible and reliable, but complex design and maintenance. Large enterprise network use that type of hybrid topology. That hybrid topology means is the mix of one or two or more than two topologies. And network topologies, if we say the mesh topology, mesh. So here, every device connect every other devices. Look here, and is the connection. Look, if we see previous, just one single node, and also if we see here, also one single node, just single node, but not when that means this single node, but in this case, they connected each other. If all four collapse, but they can connect each other. Look here, it's connect with this connect with this connect with this. All are connected, internally connected. This it's also called the full mesh. Sometimes have the partial mesh. So it high reliable and but it expensive and complex to set up. And that type of network topology used in military network, Internet of Things, IoT mesh network, etc. And this is the full mesh network. This is the half or partial mesh network. One point-to-point topology. Look here is the direct connection between two nodes. Direct connection between two nodes. Here, workstation and connect to the desktop. So point to point, a computer connect to a printer. It's also the peer-to-peer topology. And so here, different types of connection we have seen, and we also seen the mesh network, fully connected mesh topology network, then a star topology, ring topology, bus topology, etc. If we summarize all of these bus, star, ring, mesh, tree, and hybrid, then we can say that, just comparison here, bus scalability is low, but fault tolerant low, because any single point break, then all network collapse. Cost is low, complexity also low, but a star is the moderate, and also the tolerance is moderate, low medium cost, but complexity low. Ring network is moderate, low or fault tolerant. One node fails, then ring breaks. Cost is medium, also complexity also medium. Mesh network is a high scalable, very high tolerant redundancy path, very high cost, and high complexity. Tree network also high scalability, and fault tolerance is moderate, root dependency on the root, and medium high cost, medium complexity. But hybrid is the high scalability and high but dependent on maximally fault tolerant, cost high, complexity very high. So is the comparison of topologies, that is network topologies, bus, ring, star, mass, tree, hybrid, all are the physical structure. So from that topology, what type of topology choose for the business? If we see here, choose for the right topology, a small office or home, they can choose a star topology because it is simple and cost effective. And also, if the enterprise network or organization, they can choose tree or hybrid. And a critical system, if we see, then have to choose the mesh topology. For example, banking, core banking solution, that means defense, etc. And legacy system, that means old system, that can be choose bus or ring, old comparability, etc. And network topology, basically its impact based on organization need, and choose the based on organization necessity, cost, reliability, maintenance, etc. So that type of topology we can choose for a specific organization. And if we see here the network architecture, we know there are two types of network architecture. That is peer-to-peer network, P2P, and client-server network. Peer-to-peer network, look here, this is the peer-to-peer network, is a type of computer network where each device, that is peer, each device act as both of client and server. But in this architects, resources such as file, printer, internet access share directly among devices without a central server. They can share their files, also can print through the internet, because here is declared as a server, so they can share each other through that device their necessary document, file, etc. And this is the client server that declare as a server, and these devices are as a client. So here, there are two types of, look here, this is the client, the internet, and the server. And client-server network architecture is a model where client devices require services or from a central server. Look here, this is the central server and link with different PC. That PC declare that is this declare as the server, but is the client. So client-server relationship or network, client-server network. That means centrally managed. This is the centrally data here, and it offers centralized control, all control within the center, and a better scalability. And this is for ideal environment for the business organization, and require the more setup maintenance. And then peer-to-peer network. Peer-to-peer network is simple than client-server network. But here, central server manage everything here. Here, the network protocol. A network protocol like a language. The device is used to understand each other, exchange information correctly. That means network protocol, just like language, because devices are want to talk each other through that protocol. And also we know the network protocol is a set of rules, standards that determine how data transmitted and received across a network within that network. It ensures the devices, for example, computer, router, server, can communicate effectively. And that means regardless of their hardware and software, different hardware, software, but they can talk each other through that network protocol. Look here. Here are the example of network protocols. Here we have few example. For example, HTTP and HTTPS. This network protocol for web communication, and also FTP is that for the file transfer protocol. Then TCP/IP, that model that for data transmission over the internet, and HTMP, that type of network protocol for sending emails and others, and DNS, that type of network protocol for converting domain name into IP address. If we see right side here, HTTP, that how they work, HTTPS, FTP, file transfer. That means we know the HTTP is hypertext transfer protocol. Is the web transfer protocol, request response, but it's not secure. Secure is this one because HTTPS, hypertext transfer protocol, secure. So here, secure communication, it's use the STL SSL encryption. And FTP, we know the file transfer protocol. This file transfer protocol is the transfer files between the computers. And TCP, transmission control protocol, is reliable communication and connect, that means each other. Then IP, internet protocol, we know the internet protocol, that means here data transmit, routes, data packets, etc. And UDP means user datagram protocol. It means the connection. So for the communication. Then SMTP, simple mail transfer protocol, is for the email server or simple mail transfer, send email message through STMP. And SSH, secure shell, that means remote access through the SSH. So that type of here network protocol we have, if we see here, This is the client, IP packet, internet is the server. And we know the network protocol are set of rules. That means a few standards and convention that governs how devices communicate and exchange data across the network. And if we see here, the how TCP work, TCP work this way, because a TCP network refers to the computer network that utilize the transmission control protocol. We can say that TCP for communication. And user diagram protocol, UDP, is a communication protocol. This working this way. And SMTP, that means simple mail transfer. Look here how they work. It work mail send through the SMTP, sender's mail server through the internet, receiver email server. Then here the receiver through the IMP receive the mail. See the SMTP, simple mail transfer protocol. Now the switching. What is switching? But switch. That means switching is a process of transferring data packets between devices on a network. Here using the hardware devices, and we can call it the network switch. So look here, this is the network switch. Here transmit the data through this center to another center through this switch. So here switching is the process of transferring data packets between devices. Look here, PC1, PC2, PC3, PC4 is the devices on this network. And using a hardware devices called a network switch, this one. So it operates in the data link layer. We will discuss the layer in below today. So on the OSI model using data link layer, that means layer 2, OSI model have the 7 layer. So here layer 2, they address the forward data. And we know the computer network switching refers to the process of forwarding data packet between network devices. There are three main types of switching. That is that sending that type of data. That means circuit switch, message switch, and packet switch. Each method differs in how it establish, connect, and transmit data. So we can say that switching or is the process of transforming data packet between devices on a network using a hardware device. That hardware device is switch, and that type of switching, three types: circuit switching, message switching, packet switching. And if you see the circuit switch, the circuit switch, look here, this is the circuit switch. So that circuit switch is a networking method that a dedicated communication path is established between two endpoints for the entire duration of the communication. One point is here, another point is here. So establish establish a communication path. Look here. Here, the communication path. Here, establish a communication path between two endpoints, one point and another point. Duration, that communication period, duration. It ensure continue exclusive with the path commonly in traditional telephone line. And that means here saying that hello or other thing, and that connect to the receiver. But message switch, that previously it was circuit switch. Now the message switch, look here, sending the message in a network is a one kind of technique where whole messages are sent from a source of destination, one hop at a time, sending message, all message to the sender, to the receiver, sending message by the sender to the receiver in at a time. Each intermediary node store the entire message, check the destination, and forward it to the next node. This store and forward method was an early form of the data transfer used before packet switching. So we'll see the packet switching. So before establishing or inventing packet switching, message switching was popular. Now the packet switching within a packet. Look here. So packet switching is a networking method. Data is broken into a small packet that travel independently across the network. Each packet may take a different route, but they assemble at the destination. Look here. Here saying the hello. So hello, in different route, they come, they establish a, that means reachable through the destination, come to the receiver in the same way. But their destination is, they reach their destination, but the route is different. That allow the efficient use for network resource and transfer communication. And packet switching, that messages are divided into fixed or variable length packet. And packets are sent across the network. So is the packet switching. Now the network interoperability. So network interoperability, it refers to the ability to different system or devices or applications or software or network to work together seamlessly. They can exchange data, each other, and use the information effectively without compatibility use. But that means each and every system can talk each other through the interoperability, because different system, different software, different devices, they can use the data or exchange data each other. So is the interoperability. For example, we can, if I want to send my Bikash balance to Nagod, and from the Nagod, I want to send money to my relative who is using Nagod, have the account in Nagod. So I have to send money to the Nagod, but if I able to send money through Bikash to Nagod directly, is the interoperability. Or if I want to deposit my Bikash balance or Nagod balance or Rocket balance to my bank account, or also from the bank, if I able to collect or withdraw money, or that means that, or also if from my bank I want to send money to another bank, that can be possible through interoperability. So interoperability is refers to the ability to different systems as well as software, devices, application network, they to work together and exchange data each other. telecom satellite network that means telecom satellite network is a communication system, and this system use satellite, ground station, supporting technologies to transmit its voice, data, video signal, etc. And telecommunication data transmission involve sending and receiving signal between 2 points. This point, another point. Between 2 points through the satellite, antenna, or radio towers. In this case, two key principles. One is uplink, another downlink. Uplink means is the transmission of signal from the earth station or devices to the satellite center or central communication point. Here sending data to the satellite is the uplink. And downlink is the transmission of signal from satellite back to the earth station or user devices. For example, we are receiving the satellite TV, internet from the satellite, and also this is the downlink. And by receiving the signal through satellite in orbit, this network enabled to long distance communication, especially in remote or different area and different structure also. So here, uplink, that means sending a TV broadcast signal to a satellite. Here, uplink, this is from this point, transmit data to sending the data to the satellite. For example, sending a TV broadcast signal to a satellite. And from here, this is receiving the satellite data, for example, TV or internet. This is the downlink. So here, uplink, downlink, it can be MCQ. Now the virtual private network, we are familiar of it, VPN. And VPN, that means here, VPN is a secure an encrypted connection between a user device and a private network over the internet. And we know, and this feature is that means the encryption, that means keep data secure and private during the transmission. And remote access can be possible, enable to employees to access company's system from anywhere. And that means makes user IP address, and also the here, if we see the example, a remote audio station VPN secure access, also CPFN. So also we can say here is it allows the user to safely access network resource and transmit data as they were directly connected to a private network. And so a virtual private network is a secure, encrypted connection between a user's device and a private network over the internet. And our TCP/IP model. We know that TCP means transmission control protocol. IP meaning internet protocol. So TCP/IP model is the fundamental communication framework. We know that used for networking and internet. So this TCP/IP model have 4 layers. 1, network access layer. 2, internet layer. 3, transport layer. 4, application layer. And each and every layer work differently. For example, if we see the network access layer, is manage the physical transmission, for example, Wi-Fi, Ethernet, etc. An internet layer that is handle addressing the routine using the IP address. And transport layer enable the reliable data transformer using the protocol like TCP and UDP. An application layer, that means infrastructure interface, where we are seeing here, use the software, web, email, transport, etc. And it defines how data is packaged, addressed, transmit, routes, and received between devices. TCP/IP model defines how data is packaged, addressed, transmitted, and received between the devices. This is the how TCP work. Look here, sender sending the message through the packet and receiver receiving it. So here we have seen the four layer of TCP/IP. It can be MCQ. How many layers in TCP/IP model? So here four layers. Network access layer, internet layer, transport layer, application layer, and each and every layer and work differently. But combination is that they can define how data packets address and receive between the devices. And we can say that here when we visit in website, that type we are seeing HTTP, that means application layer. If we see the website, we go any website, we are seeing the HTTP, that means is the application layer. That means interface. Then sending a request over the TCP, that TCP, transport layer. Then which travel using the IP, that means internet protocol, IP layer, internet layer, through a physical network. That means access layer. Now the OSI model. We have seen TCP/IP model. It's a 4 layers. But OSI, that means Open System Interconnection, that model has the 7 layer. So what 7 layer? Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. But interestingly, that layer are only taken from that 4 layer of TCP/IP model. So the OSI model is a conceptual framework that is standardized how computers communicate over a network. It's developed in 1980 by the ISO, International Organization of Standards, It defines 7 distinct layers, each with a specific role in the transmission of data. মুত্তাকিন, এই দরজাটা একটু করে দিয়ে দাও, এইটাকে একটু আওয়াজ আসে তো, পুরা লাগবে না, আপনি রাখবেন। থ্যাংক ইউ। So OSI model helps troubleshooting network problems by isolating, that means issuing a specific layer. It's enable interoperability among the different vendors and technologies. OSI model provides a universal standard for designing and managing the network. And same way, the physical layer is that transmits raw over the cable radio, data link with the data, network, this using the logical address, transport is the TCP UDP, that means data delivery. Session layer is the manage the session or connection between the application, and presentation layer translate, encrypt, and compress the data. application layer also same as the interface with the end user software, etc. So that layers are, look here, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. 7 layer in OSI model. So here MCQ is how many layers in OSI model, network model? Answer 7 layers. And now the compare between TCP IP model and OSI model. If we see here, look, TCP IP model, here the application layer, that application layer divided 3 layer in OSI model. TCP IP model on one layer, application layer, that application layer divided 3 layer in OSI model. That are application, presentation, and session layer. Transport layer is the same as TCP IP model and OSI model. And also the network layer in TCP IP model is same as OSI model. But network interface, that layer is divided 2 layer in OSI model, data link and physical link, physical layer. So here we know that TCP IP model is similar, real world, and widely used in internet. And OSI model is a detailed theoretical framework useful for learning and design. And if we see here, the that versus TCP IP model versus OSI model, pull from, we know the TCP IP model is transmission control protocol, internet protocol, and OSI means open system interconnection. Developed by this TCP IP model developed US Department of Defense, but OSI model developed the ISO, International Organization for Standards. We know the TCP IP model, they have the 4 layers, but OSI model 7 layers. Is the layers name here, application, transport, internet, network access, etc. Are here the application, presentation, session, transport, network, data link, and physical layer. Approach and model type, here the protocol oriented TCP IP model, and practical and implemented. But OSI model is the model oriented and theoretical and conceptual. Reliability provided by TCP IP model is the transport layer TCP, but OSI model transport layer but control the clearance. And data flow control in the TCP IP model within the transport layer. But OSI model separate across the multiple layer. TCP IP model used in internet communication. OSI model used in teaching and conceptual modeling. TCP IP model protocol specific, that means TCP and IP suite. But OSI model protocol independent. Now the telecommunication network security is taken from the CISA. So telecommunication and network security that focus on securing data transmission across the network by ensuring confidentiality, data integrity, data availability, and data authentication. And also, you know, it includes the encryption, data encryption, firewalls, and the secure protocol that protect against the threat like DOS, we'll learn it later on. So here telecommunication and network security in different way. Sometimes that attracts through the network, and look here, that type of network attracts can be happen. So network refers model here using the OSI model or TCP/IP model. Network component, we know the network components are a protocol, cable, router, switch, access point, etc. And network security through the one LAN and users, and the network type different steps, one LAN, MAN, PAN, etc. So here's the network security. Now, based on our discussion, we will see few MCQ. Which OSI layer ensure reliable end-to-end message delivery? Which OSI model? We have seen there are 7 layers in OSI model. So which layer ensure reliable end-to-end message delivery? That means transport layer. That transport layer is layer 4 that handle the flow of control and error recovery. So here answer is B. So transport layer of OSI model ensure reliable end-to-end message delivery. Answer B. Now, what is the primary advantage of a star topology? Primary advantage of star topology. Star topology easy to troubleshoot because is the centralized connectivity that simplify problem isolation. So here, primary advantage of the star topology is easy to troubleshoot because star topology connected centrally. Answer B. Now, what does MPLS stand for the networking? We know the MPLS is the multi-protocol level switching. So, multi-protocol level switching use levels of efficient packet forwarding in carrier network. Answer A. In which topology does a single cable failure disrupt all communication? Here, 4 topology are star, mesh, bus ring. Here, bus. Because bus topology fail completely if the backbone cable is served. So here, bus topology, if a single cable failure that disrupt the whole communication or whole network. Answer B. C. Which architecture is commonly used for file sharing application like BitTorrent? Okay, so here peer-to-peer architecture is commonly used for file sharing application. Peer-to-peer architecture, network architecture, is commonly used for file sharing application. We know the peer-to-peer, P2P architecture are ideal for distributed file sharing. Answer B. In a client-server architecture, what happens if the server fails? Client-server architecture, what happens if the server fails? We know all client lose access to server resource because client-server system have a single point of failure at the server because they're connected with the server. So if server loss or fail, So all client or point or PC or station cannot access to the server because all client lose access to the server resource. Answer C. What is the main advantage of packet switching over circuit switch? We know more efficient bandwidth utilization because all messages divided into few packet. So that packet run within the network and accumulating receive to the receiver. So packet switching allows multiple communication to share the same network resource. So main advantage of packet switching over circuit switch, that more efficient bandwidth utilization. Answer C. Which switching technique stores and forward entire messages? Which switching technique stores and forward entire message? We have seen there are three types of switching. We have seen one is circuit switch, another packet switch, another message switch. So in this case, message switching, this technique stores and forward entire message. So message switching store the complete message at intermediate nodes before forwarding. Answer C. What is the most fault-tolerant topology within the four? Here, mesh topology is most fault-tolerant because mesh network provide multiple paths, ensuring redundancy. Answer D. Which topology use a single backbone cable? We have seen a single backbone cable use the bus topology. Single backbone cable used by the bus topology. So a bus topology connects all devices to a single communication line. Answer B. Now, which architecture is more scalable for large enterprise? Here, we have seen P2P means peer-to-peer, client server. So here, client server network offers better scalability and centralized management. So client server architecture is more scalable for large enterprise. Answer B. Which protocol is used for email transmission? Here, four protocol. So here we know the SMPT, that means simple mail transfer protocol, sent email between the server. So SMTP, that means simple mail transfer protocol, is used for email transmission. Answer C. In a peer-to-peer network, what is the key characteristics? We know here all devices act as both client and server. So peer-to-peer network allows share resource without a central server. Peer-to-peer network. Here answer B. Which switching type is used in the internet? Internet use packet switching because the internet use packet switching for efficient data routing. Answer C. So packet switching is used in the internet. Answer C. Which switching method establishes a dedicated path before transmission? We know circuit switch. Circuit switch sets up a fixed path, traditional phone line, etc. Answer C. So we can say circuit switch method establish a dedicated path before transmission. What does network interoperability ensure? Network interoperability ensures is that different system can communicate seamlessly because interoperability allows devices or systems or software or application to exchange data efficiently within the system. Answer B. Which protocol ensure interoperability in web communication? So we know HTTP or HTTPS protocol ensure interoperability in web communication because HTTP or HTTPS is a universal web protocol enabling cross-platform communication. Answer B. What is the primary purpose of VPN? We know is provide secure remote access over public network. So primary purpose of VPN is providing secured remote access over public networks. We know the VPNs encrypt data to ensure secure communication over untrusted networks. Answer B. At which OSI layer do routers operate? We know network because is a layer 3. Routers function at the network layer for IP routing. So network ISO layer do routers operate. Answer B. Which layer in the TCP IP model corresponding to the network OSI network layer in the OSI? So here corresponding layer is internet because the TCP IP internet layer align with the OSI network layer. We have seen. Answer C. Which OSI layer is responsible for encryption and decryption? We know the presentation layer because the presentation layer handled data encryption and compress through the SSL, TLS, etc. Answer C. Which of the following is not a common network security threat? Phishing is a threat. DDoS attack threat. Man-in-the-middle attack is also threat, but firewall is not a threat because a firewall is a security measure, not a threat. Phishing, DDoS, and man-in-the-middle are security threat. Answer C. So we have complete telecommunication network as the part 2. So we'll take 15 minutes break. Then then again we'll start another within LO-06. Here we will discuss the cloud technology. So till then, 15 minutes break. Okay, sir. আমরা 15 মিনিটের জন্য একটু বিরতি নিচ্ছি স্যাররা।
ওকে
ঠিক
স্যার।
আছে? ওকে স্যার।
ওকে স্যার।
স্লো স্যারেরা আমরা শুরু করি এবার।
जी सर।
থ্যাংক ইউ। So we'll come again. We are in information technology, CS certificate level. So we are in learning object 6, telecommunication network. Within this learning object also included cloud technologies and Internet of Things. So now we will go for discuss the cloud technologies. Cloud technologies. Cloud technologies, look here. Refers to the delivery of computing service, including server, storage, database, networking, software, etc., over the internet through the cloud. And sometimes is a pay-as-you-go basis. So cloud computing, on-demand self-service. It has the broad network access. It has the broad network access and elastic resource pooling, rapid elasticity, measured service, and cloud computing are different types. For example, here we can use it as a storage, as server, where application, database, and that cloud computing is different types. For example, private cloud, public cloud, and hybrid cloud. Hybrid cloud combination of private and public cloud. So cloud computing, we know that there are a lot of advantages we have, because without coding or without establish any software, we can use the software as a rental basis. Cloud service provider, they provide the software for use for nominal fee, and we can take it for data security, also backup, storage, server, and it has the flexibility, low maintenance cost, its mobility is high, and service is pay per use. So that cloud computing has the architecture, and that the cloud computing architecture are front end and user side. Front end is the user side, what we are seeing in the front side. Then back end in the cloud service provider side. So within the back end, the data center and infrastructure is there, but front end, what we are seeing in the front side, we can use, and that two type of connection through a network, usually internet. Through the internet, front end and back end of cloud structure that connect through the internet, and front end is the user side. It can be MCQ. So in the cloud computing, the user side is front end. And in the cloud computing architecture, in cloud computing, back end side is cloud service provider. If we see the types of cloud computing or development and our model, there are public cloud. For example, shared infrastructure, as we see in Amazon and other thing. And private cloud, that means dedicated infrastructure. And hybrid cloud is a combination or combined of private and public cloud. And multi-cloud also, we have user service from the multiple providers. And look here, cloud provides own and operate hardware. Cloud providers own and operate all hardware, software, and the other supporting infrastructure. If you see, the public cloud is a type of cloud computing where third-party providers offer computing resource. For example, server. We can use server without having the server. We can store our data without having the server. And we can use the software or application without own the application or software, just provided by the cloud service provider through or over the internet to multiple user or organization. It is very much popular at this moment because these resources are shared among different customer, multi-tenancy, and are typically accessed via web browser or API, through the API. So here, cloud computing, different types, private, public, and hybrid, multi-cloud, etc. This cloud provider, they own the all operational item. For example, hardware, software, supporting infrastructure, all owner is the cloud service provider. And if you see the private cloud is dedicated cloud infrastructure for a single organization, hosted on premises or by the third party. And here, the ownership of this private cloud, organization can control it. Cost model is high because hardware, software owned by the organization, but public cloud that owned by the service provider, cloud service provider. In the security side is the more secure, and compliance side is idle regulation. That means, for example, it use government and healthcare, etc. The private cloud for the government, and private cloud is computing resource dedicated exclusive for the organization. A private cloud delivers a high level of security and privacy that public cloud by offering dedicated resource to the companies. We know that type of private cloud use in banks handle sensitive transaction or data, millions of data, sea of data. Also government agencies and sorry, now the hybrid cloud. So hybrid cloud is the combination, private and public cloud. And if you see here, look here, is the private cloud private cloud and public cloud. Private cloud on the premises of the organization, public cloud, this service provider provide that type of service. So combination of that is hybrid cloud. And sometimes that e-commerce and other healthcare and multi-manufacturing organization use that type of hybrid cloud. Its most popular third-party cloud providers offer hybrid cloud. And if we see the multi-cloud, user and multiple public service provider, and key features are diversification and best of that means use it, resilience is across the provider, and global app need that type of cloud computing. And if we see if we compare each and every that means public, private, hybrid, and multiple control Public cloud is low. Operation, that means that cost is OPEX, that means operational expense or operating expense. Operational expense, scalability high, best for the startup company. And SaaS, that means software as a service. That means that software service provided by the cloud computing. A scalable app use. Private, that means high control within by the organization. At that type of cost, capital expenditure. But here the operating activities, about operating expenses. Scalability moderate. Regulated industry can use that type of private cloud computing. Hybrid is the mixed cost and also multiple, also very high scalability, but cost is variable based on size and complexity. Now, that type of cloud computing have different type of service. That service are, this way we can categorize various type of service, commonly infrastructure as a service, platform as a service, software as a service, commonly known as SaaS, PaaS, IaaS, and function as a service, FaaS. So look here, SaaS, software as a service from the data center, software cloud service provider provide the service to the user or organization, the software used by the organization, but ownership of the software is the service provider, not the organization, but they can use it by paying nominal fee. So use the cloud hosted application, SaaS. Same way, PaaS, that means platform as a service, sometimes use the platform for the operating, creating the operating system or different types of apps, for example, mobile apps and other thing, manage the database. So that type of platform can be used through the cloud computing, and that type of facility given by the service provider. So also the platform as a service. Same way, infrastructure as a service, sometimes a few infrastructure service can provide by the cloud computing service provider and used by the organization or developer to develop any type of software and other things through this type of use that software or infrastructure. And if you see the infrastructure as a service that provide virtualized infrastructure, and platform as a service, PaaS, that offers platform for app development or for the development. SaaS, software as a service, that deliver the ready-to-use software over the internet. FaaS, function as a service, that event-driven serviceless computing, that type of service providing by the service provider, that means through the cloud. So we can say there are different types of service, that means computing service providing by the cloud service provider. They're basically infrastructure as a service, platform as a service, software as a service, function as a service. Now the infrastructure as a service. If we see the infrastructure as a service, is a fundamental cloud service provider layer that allows the organization to rent IT infrastructure, for example, server and data storage, network, operating system from a cloud provider. For example, DevOps team, we know it. You will learn from learning update 1 or 2. DevOps money, that means development and operation. When one team, software development team, develop the software, and in the same time, they use it for the operation. So DevOps team can use infrastructure as a service as an underlying platform from which to build the DevOps tool chain, which can be include the user various third-party tools. It has some advantages. That means no need for expensive private infrastructure. If any organization want to establish infrastructure, IT infrastructure, need to invest huge amount. So if cloud computing service provider provide the infrastructure through nominal fee, so that type of infrastructure can be used by the organization for develop the software. That when develop team can use that type of advantage from the cloud service provider. So based on that, if use that type of platform by the organizational people, then that can be no need for expensive private infrastructure by the organization. And easy to hardware accessibility from that type of service and better resource utilization. And also pay-as-you-go business model use here, because that means platform stage and that means কতটুকু আমি ব্যবহার করছি, based on that pay-as-you-go business model is used here. So here the different type of server used in infrastructure as a service. For example, physical server, dedicated virtual server, share virtual server. So physical server, that means hardware, is allocated for the customer dedicated use. One server through the cloud used by the organization, physical server providing by the service provider. And one dedicated virtual server is allocated, which run on a physical server that may have other virtual server also. And share virtual server access to the virtual server, which may be shared with other customer. A partial can be used by an organization allocated site. So we can say infrastructure as a service is a fundamental cloud service layer that allows the organization to run IT infrastructure for use as a server, as a data storage, as a network, as an operation activity from a cloud provider. Now the platform as a service is a cloud infrastructure built on a infrastructure as a service that provide resource to build user level tools and application. It has some advantages because total cost lower of because no need for ownership. So cloud service providing that type of facility, platform as a service. Within the platform, the infrastructure as a service also, and lower admin overhead, more current system development, and increase the business and IT alignment. A scalable solution can be possible. It is the advantages of platform as a service. But disadvantage some, it have a security problem, portability and trust related, can be data misuse of that organization. And platform as a service, that the customer can then simply upload an artifact and application cloud code. They can automatically deploy to the infrastructure of a platform as a service. Now the software as a service. SaaS, software as a service, we know that deliver the software application over the internet on demand and typically use subscription, based on subscription, we know the each and every item used, then yearly have to pay. That means the subscription have to pay. The cloud provider hosts the manage the application, address the software upgradation and security patch as needed. So all activity done by the cloud service provider. But organization can use the software by paying the subscription yearly basis or monthly or the yearly maintenance basis. So software as a service, that application through the internet based on the demand, organization can use it by paying the subscription. It has the characteristic. For example, is the one-to-many. For example, one software can use many. If see the Tally software, if you think most cheapest software, so one Tally software use many. And web access also here, centralized measurement, multi-devices, better scalability, high availability, API integration. We know the API. API means application programming interface. So if you want to link one software to another software, you have to link, you need the source code. So through the API, one software can link with another software. For example, NVR e-return server, NVR's e-return server add bank's core banking solution through the API. And near future, all accounts transaction can be accessed by the NVR. So through that API, one software can another software can link. So you have seen that. Look here, software as a service, SaaS, platform as a service, use the platform, infrastructure as a service, use the infrastructure. So here, software as a service, use the hosted application, and all sometimes it can be data center, and platform as a service, develop tools and data management, and infrastructure as a service, operating system can be infrastructure are there, and server, storage, network, etc. Now the function as a service. So function as a service is a cloud computing service that allows customers to run code in response to events without managing the complex infrastructure typically associated with the buildings and launching the microservice application. So function as a service is a cloud computing service, allows the customer to run code in response to the event. That means based on the function. So if you see this one, right side, look here. So hardware that can be virtual, server, storage network is the infrastructure as a service. And if any organization want to use that type of service from the cloud service provider, they have to pay monthly basis or weekly basis or hourly basis or minutes basis. Pay as you go model. And if we see the platform as a service, that when platform, how many times use the run times, operating system use, middleware use, that provision the time, minutes or second that can be used here. And if you see the application, that means the software as a service, the provision of time, second and millisecond used by the organization that have to pay
পাইছি আলহামদুলিল্লাহ। যদি এগুলি দেওয়ার থাকে মিলা দিয়ে দিলে।
না, আমি কে বলবো, মনি তো উপরে।
মনি আসুক একটু
আমি তো সবার লগে।
হ্যাঁ, শেষ হয়েছে সব খাওয়া দাওয়া সব শেষ।
খাওয়া কথা বল।
এই চার্টার অ্যাকাউন্টেন্ট এটা অফ করেন
তোমাদের খাওয়া দাওয়া সব শেষ।
খাওয়া শেষ হলো এই গুলো
না না সেটা ঠিক আছে, মানে খাওয়ার সময় টান পড়ে নাই।
না না।
যারা কো-হোস্ট আছেন ওনাকে একটু মিউট করে দেন।
এই
সরি স্যার, সরি।
না না ঠিক আছে, খাওয়া দাওয়া শর্ট করে না বলছি, ভালো কথা। এটা তো শীতের ভিতরে খুব ভালো হয়েছে, নাহলে তো আবার রান্না লাগতো যে। আচ্ছা, অ্যাপ্লিকেশন গেল, দাম হলো ফাংশন। তো ফাংশন অ্যাজ এ সার্ভিস, এটাকে কি করা হয় যে আপনার দেখেন যে প্রভিশন টাইম বা মিলি সেকেন্ডের সময় হিসাব করা হয়। সো উই ক্যান সে দ্য ডিফারেন্ট টাইপস অফ ক্লাউড কম্পিউটিং সার্ভিস উই হ্যাভ: infrastructure as a service, platform as a service, software as a service, function as a service. Now the community cloud, another item. That community cloud refers to a shared cloud computing service environment that targeted the limited set of organization or employees, such as bank or different types of firm. Look here. Here the community cloud that use all software as a service, platform as a service, infrastructure as a service by different organization within a community. So it's the community cloud, specific for that community. Now we have seen the pay-as-you-go PEG cloud computing model. What is this? So pay-as-you-go pricing model means that users pay based on how much they consumed. Same way, if we use our mobile data without purchasing that pre-purchase, then that type of pay-as-you-go model is using there. How much data we are using, do we have to pay based on our use. So a cloud storage server provides clouds, different storage, how much we are using, we have to pay that. So that type of model is pay-as-you-go model, pricing model. Now the challenge of cloud storage. Here, challenge that security threat, reliability threat, outage, or theft. We have discussed the cloud computing, which is the on-demand access computing resource. And for example, if you store third-party our data, so security problem is that data can be misused. And reliable cloud computing service provider require sometimes the server or software can be old age or not functionable, or old but not that upgrade version. So that type problem can be happen. And also the secure data can be theft. So that type of challenge in cloud computing. Now, based on our discuss cloud computing, here few MCQ. Look here. Which of the following is true for cloud computing? Within 4 sentences, which one is true? Cloud computing enables access to services anytime, anywhere. It is true. But other 3 is wrong, not true. Data can't be accessed remotely. It cannot be. It's only for large enterprise, not only for. It increase IT maintenance. It is not true. So answer is cloud computing enables access to services anytime, anywhere. We know the cloud provides global, on-demand access to IT resource. Answer C. A cloud-based database server is an example what? Database server, cloud-based, within four, which one? Platform as a service, because platform as a service provide the platform like database for app development. Answer C. Now, a business run its ERP software using a third-party cloud provider. This is what would be the answer? Software as a service, because this is software. Software as a service. We know the ERP software accessed via the cloud is a form of software as a service. Answer A. Now, cloud storage services like Google Drive or Dropbox fall under which one? Cloud storage service is also the software as a service. Their software, Google Drive, Dropbox, and it's the software as a service. Tools provide the end user over the internet. In which model? Okay. Does the provider manage the application of operating system, OS? Here, software as a service and platform as a service. So, you know, software as a service and platform as a service, the provider manages more than just hardware. Major advantage of cloud computing for startup companies. Major advantages are scalable and low upfront cost. Because, you know, startup companies benefit from the pay-as-you-go model and quick development. So major advantage of cloud computing for startups is the scalable and low upfront cost. Answer B. Cloud computing helps business by offering flexibility and cost savings. Cloud computing helps business offering flexibility and cost saving because cloud provides a scalable, cost-effective, and flexible solution. Answer C. Cloud service that lets you run code without managing servers. What is this? Is the function as a service, is a serverless model for running code on demand. Answer B. Which of the following is the key features of platform as a service? Key feature of platform as a service is that means PaaS allows developers to build apps without managing the infrastructure. We know the platform as a service supports the app development while handling the infrastructure complexity. Answer B. An online accounting platform available via subscription is an example of what? Online accounting platform available via subscription is an example of online accounting software as a service. So software as a service delivers accounting software through the cloud. Answer C. Which cloud type would you choose for highly confidential client data? Which one will choose? Not public, because public can be leaked also. Not hybrid. So here private. Private cloud offers enhanced data isolation and compliance control. Answer C, private cloud. Private cloud choose for confidentiality for client data. A company wants to cost efficiency. A company wants to cost efficiency of public cloud and control of private cloud. Best choice is hybrid cloud. So here both private and public. So company wants the cost efficiency of public cloud and control of private cloud. Best choice hybrid cloud, because hybrid cloud offers a mix of scalability and control. Answer A. Which development model allows public cloud features within a secure private setup? We know hybrid cloud, because hybrid cloud allows secure communication between public and private infrastructure. Answer B. Which cloud model offers the highest control and security? We know private cloud. Public cloud provides are, the double. Okay, public cloud provides are offering the multiple user via shared infrastructure. We know the public cloud are owned by the third party and used by the many client. A government agency share a cloud platform with other similar organization. This type of cloud computing is community cloud, because community cloud are shared by organization with common concern or common goal, common mission, vision, etc. So here, answer C. A private cloud is typically used by one specific organization, because a private cloud serves a single organization for better control and security. Answer B. Which model allows users for focus only on writing code, while the provider handle execution? So here, function enable serverless computing. Answer C. Which service model provide virtual machine network and storage? Here, infrastructure as a service that provides core infrastructure component. So infrastructure as a service, this model provides virtual machine network and storage through the service provider. In which model does the customer manage everything except physical hardware? Which model? This model are infrastructure as a service, because infrastructure as a service, the customer manage only operating system, apps, etc., while the provider handle the hardware. Answer C. What is the data center in cloud computing? In the cloud computing, data center is a facility with networked computers for cloud services. So, a data center in cloud computing is a facility with networked computers for cloud services. We know the data centers host the hardware, server, and storage that require to run cloud platform. Answer C. Cloud computing is primarily delivered via internet. So without internet, cloud computing cannot be possible. So here, cloud computing relies on internet connectivity to deliver service. So cloud computing is primarily delivered via internet. Answer C. What is cloud elasticity? Cloud elasticity is automatically scaling resource based on the demand, because elasticity means resource can be scaled up to down dynamically to meet the demand of the organization or user. Answer B. What is the primary features of cloud computing? Cloud computing primary feature is on-demand access to computing resource, because cloud computing allows users to access resource like storage, service, software, infrastructure, all on demand via internet. Answer C. What is the following is a key benefit? Which of the following is a key benefit of cloud computing? Key benefit are pay as you go pricing, because cloud services are typically built based on the uses, making them cost efficient and scalable. Answer C. So complete the cloud computing. Now within LO-06, we have another one. That is the Internet of Things. So if we discuss Internet of Things, then we will be able to complete our LO-06. Now the Internet of Things. Look here. Internet of Things, IoT. This describes the network of physical object, that means things, that are embedded with the sensor, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. And for example, our fingering or punch, everything, that means all are the IoT. So through the sensor. So Internet things, look here, if you see the picture, all are the item or things connected with the internet, and all things that provide data or connectivity for exchanging data with the system of the organization or other things. Look here, IoT, that refers the collective network of connected devices and technology that facilitate communication between devices and the cloud, as well as between the devices themselves. It has the key features. If you see, IoT devices are connected to the internet and can collect the exchange data. It enables real-time monitoring and automation. If we see the common example of IoT is the smart thermostat, wearable fitness device, connected cars, and the industrial sensor, etc. the common example. And IoT architecture typically include device, sensor, connectivity, data processing, and user interface. And security and privacy are major concern of IoT implementation, because in finance and accounting, IoT aid of inventory tracking, compliance monitoring, asset management, and data accuracy can be possible through the IoT, and organizational activity will be simple through the IoT. So all sensor within IoT, if we see the IoT, the component of IoT, we can divide in 4 types. One is sensor and actuator, another connectivity and data processing, and user interface. 4 items included IoT, Internet of Things. Look here, sensor, that means collecting data. Connectivity, that means sending data to the cloud. data processing, that means making data useful for the organization for next use. Then user interface, that means delivering information to the user, what we have seen. So we can say main component of IoT are sensor, connectivity, data processing, user interface. Now the benefits of Internet of Things. It's of the huge benefit, for example, real-time asset or resource visibility, reduce cost, improve operational efficiency, data-driven insight of quick decision-making, improve the end customer experience, real-time predictive and prescribe the insight, end-to-end remote monitoring, and management of the asset or resource of the organization. It has the risks and challenge also. IoT offers many benefits, but it also have several risks and challenge. That risks and challenge, we can say the security and privacy risks. Interoperability issue. If any device cannot communicate with other device or no interoperability, they cannot IoT work here. So data overloaded can be possible. Same data in different storage. And cost and complexity, most here risky because have to use the devices that can be costly. And connectivity can be complexity, networking. And regulatory and legal challenge can be possible within, can happen within that type of risks of IoT. So security challenge, that means weak authentication and authorization, if have, the security problem can be happen. And if lack of encryption and vulnerability of software and ensure that cannot ensure the communication, the difficulty for the patch or update service, sometimes device can be outdated, software can be outdated. So that type of problem can be happen. And within IoT, computing is a computing model where data is processing close to the resource, for example, device, sensor, local service, or server, and instead of being sent to the centralized cloud or data center, that distributed computing model, that data processing and analyze to the network instead of background or centralized infrastructure, because it brings the computation to data delivery faster and response within the time, reduce the network load, and improve the reliability of the real-time cases. If you see here the picture, that is computing. So each and every item of connected to the internet or IoT, we can use it. Through that sensor data can be, this is the center data, this is the cloud, but sometimes that can be processed within the system, and that help to data delivery faster response time and reduce the network load also, and improve the reliability for real-time case. So edge computing, this will help to the organization. If we see the use of IoT in the industry, so if we see the smart manufacturing that connect the asset to prevent the predictive maintenance, and a smart power grid, a smart city, connected logistic, a smart digital supply chain, all industry using, for example, we're using home for the smart parameters control, optimize user, and industrially we are using machine to machine communication, quality control, automatically vehicle to diagnostic, etc., smart parking, etc. Agriculture side, we also use military side, sustainable awareness, threat analysis through the IoT, medical use, environmental use, rental, retail shop also use that type of devices for theft protection, inventory control, focusing marketing, etc. How should business approach IoT? So have to manage the IoT devices that can be complex or challenged, but there are several best practice and worldwide using the business, that type of model IoT devices are secure, reliable, and optimize the performance of the organization. It helps to achieving the organization vision or mission or goal. Have to plan the IoT strategy, then have to choose the secure IoT products or devices, then monitor and maintain the devices carefully, then manage the data efficiently, then build an ecosystem. So unlock business value, IoT that's driven data, inside the IoT data that can help to achieve the organizational goal. If you see this industry using all item as all are the IoT, Internet of Things, they can data analysis and all things go to the server and big data analysis. Then based on data analysis, they can take the decision for the business for the next level. And if you see the IoT ecosystem, look here, the IoT application for an organization, all are interrelated. Within the system, the CCTV, light, home, office, factory, supply chain, delivery, all are vehicle, all are within the IoT environment. That means IoT ecosystem. And that devices, data go to gateway, and the IoT cloud platform, then dashboard or decision making for the top level management of the organization. And if we see the history of IoT or timeline, it has started in 1974. They begin the transmission control, that means TCP and IP model when it start. Then 1990, the first IoT device introduced, and 1991, the first web page introduced. Then 1990, IoT is coined in the first time, and 2013, the first official entry of IoT, 2013. And 16 is the almost bring down the internet, that 20 IoT devices exceed 20 billion. And now 2006, 2026. So it can be double or triple. So it is the history of IoT. Now, based on our discuss IoT related MCQ, based on discuss Internet of Things related MCQs here, which of the following is an example of an IoT device? Here, 4 items. Which one is IoT device? Definitely smartwatch, the IoT device, because it can collect and transmit data via the internet. A smartwatch. Answer A. Which component is not a typically part of IoT architecture? Here 4 items. So here, sensor is a part of IoT, network part of IoT, data processor part of IoT, but operating system is not part of IoT, Internet of Things. We know the operating system is not a required for IoT architecture component. Answer D. Internet of Things devices primarily use which of the following to connect to the internet? Wi-Fi. IoT devices commonly use Wi-Fi or mobile network. Answer C. What is the major benefit of IoT in business operation? Major benefit are real-time data collection. So IoT allows real-time monitoring and decision-making. Answer B. Now what enable IoT devices to sense their environment? Sensor, because sensors detect physical inputs like temperature or motion. The answer B. Sensor enables the IoT devices to sense their environment. Which of the following is a challenge of IoT? Challenge it security vulnerability, because IoT devices are prone to cyber attack. Anytime can be happen. So answer C. Internet of Things data is typically transmitted via which medium? We know radio wave, because IoT data commonly use wireless radio wave. A smart thermostat is an example of IoT in home automation, because smart thermostats automated home temperature control. Answer C. Which layer in IoT architecture process and analyze data? That layer are data processing, because data processing layer is the layer where this handle the collected data. Answer D. So we can say data processing layer in IoT architecture process and analyze data processing. Which technology allows multiple IoT devices to communicate wirelessly over short distance? We know the Bluetooth, because Bluetooth enables short-range wireless communication. Short-range wireless communication enables through the Bluetooth. Answer B. The things in IoT refers physical object with connectivity. Internet of Things, that things means physical object with connectivity. They are connected physically devices like sensor or other appearance, etc. Answer B. Internet of Things can improve inventory management by live tracking of goods, because IoT sensor and track stock in real time. Answer B. Which of the IoT risks impact privacy? Data breach, because unauthorized access to personal data is a major risk in this case. Answer C. Which of the following is a real-time IoT application? The smart parking system is provide the live update of the slot available. Answer B. Which cloud model is most used for IoT data storage? That cloud model, public, because public cloud is scalable and widely used for IoT data. Answer B. Internet of Things devices must be able to connect and communicate, because interconnectivity is key for Internet of Things functionality. Answer A. So, sir, we have complete our learning object 6, and within 6, we have seen the network, telecommunication network, Internet of Things, and other things which as part of syllabus. So, Sarara, do you have any question? এই কোনো কথাবার্তা আছে স্যারেরা?
স্যার আমাদের এই ক্লাসগুলো শেষ হওয়ার পরে কি আমরা কোনো প্রবলেম সলভিং ক্লাস পাবো?
যদি ইয়া করা হয়, যে একটা মিনিট, হ্যাঁ হ্যালো, আসসালামু আলাইকুম। যে ঠিক আছে স্যারেরা, আমরা আজকে ক্লোজ করি। আর ওটা যদি সম্ভব হয় আমরা ইয়ে করবো আর কি। এদিকে আপনার আরেক স্যার তো পড়াচ্ছেন, আমরা শেষ হয়ে গেল। আমি লাইনিং এর মধ্যে 3, 4, 5, 6 এই কটা শেষ হয়ে গেল, হ্যাঁ। আর হলো নেক্সট ক্লাসে হবে 7, তারপরে হবে 7-এ আমাদের 2টা ক্লাসই শেষ হয়ে যাবে। এরপর 8 থাকবে, 8টাও আমার সম্ভব হলে আমি নিব, অসুবিধা নেই, আমাদের যেহেতু সময় আছে। তো স্যারেরা আজকে ক্লোজ করি, যদিও সময় আমাদের হাতে আছে। ঠিক আছে, শীতের রাত, আজকে ক্লোজ করা হোক, ঠিক আছে?
জি স্যার, জি স্যার।
ওকে, ভালো, সবাই ভালো থাকবেন, আবার দেখা হবে ইনশাল্লাহ। জি, আল্লাহ
আসসালামু
হাফেজ।
আলাইকুম।
ওয়ালাইকুম আসসালাম।
আসসালামু আলাইকুম স্যার।
Yes, sir. Thank you.